So how do we do matrix operations on our Casio graphing calculator? Firstly, to enter a matrix on your calculator, the easiest way to do it is on the main screen. You go to Math, F4, then you choose Matrix Vector, which is F1. Then you have to choose the dimensions of your matrix. Let's say that we're going to add or subtract two 2x2 matrices. Let's say we have these two matrices, 3, 1, 0, 5, plus another matrix, which is 5, -1, 7, and 4. Now, when I add two matrices, they should be the same dimensions. So this is a 2x2 matrix, and this is also a 2x2 matrix. Each one of them has 2 rows and 2 columns. So each one of them is 2x2. The resulting matrix should also be the same dimensions, because if we want to add these two matrices, we add 3 plus 5, which is 8, 1 plus -1, which is 0, 0 plus 7, which is 7, and 5 plus 4, which is 9. So this is also a 2x2 matrix. Let's try to do it on the calculator. Now we have the 2x2 here. It's already given as one of the options, so it's F1. Now when I enter the numbers of the matrix, I enter them row by row, and I only move with this arrow, the right arrow. So 3, 1, 0, 5. Plus, the other matrix is also a 2x2 matrix, 5, -1, 7, and 4. Yeah, so the result is the sum of the numbers in each matrix. And if we want to subtract, we do the very same thing. So we just change the plus with the minus here. 3 minus 5 is -2, 1 minus -1 is 2, and so on. Now, if you want to multiply two matrices, the number of columns of the first matrix should be equal to the number of rows for the second matrix. Let's consider the example here. So the first matrix is a 2x3 matrix, so it is 2x3, because it has 2 rows and 3 columns. The other matrix should be 3 by something, so the number of columns here should be equal to the number of rows. So in our matrix here, we have only 3 elements. So we have 3 rows and 1 column. So this is a 3x1 matrix. The result of this multiplication should be 2x1. Let's try it out on the calculator. So firstly, I want to enter a 2x3 matrix. I don't have it here as one of the options, so I'm going to choose m by n, F3. M is 2 and n is 3. So it's a 2x3 matrix. Okay. 1, 0. As we said, we enter them element by element by moving to the right, or by using the right arrow. 7, -5, and 4. So this is our first matrix, times the second matrix, as we said, is a 3x1. We already have it here, so we click on F5. 5, 7, and 2. The resulting matrix is a 2x1 matrix. So we have 9 and 8. How did we get these two numbers? Let's try it out without a calculator, just to understand how the multiplication process is done. So in order to multiply these two matrices, we should multiply each row by each element in the other column, in the other matrix. So we multiply 1 by 5, which is 5, plus 0 by 7, which is 0, then plus 2 by 2, which is 4. 5 plus 0 plus 4 is 9, so the answer here is 9. So by multiplying row 1 and column 1, we got element 1, 1. Let's say we have matrix A, so this is element A1, 1, 1, I mean. Now for the other element, how did we get the 8? We multiply this by this. 7 times 5 is 35. -5 times 7 is -35. And 4 by 2 is 8. So these cross out. The answer is 8. So element A21, second row, first column, is found by multiplying the second row of the first matrix and the first column of the second matrix. If you're allowed to use the calculator, just do it on the calculator. Now, let's say that we're going to find the inverse of a matrix. Actually, we cannot divide matrices, and we can only add, subtract, or multiply matrices, but we cannot divide matrices. Now, in order to find the inverse of a matrix, it has to be a square matrix, and it has to be a 2 by 2 matrix, or a 3 by 3 matrix, or a 4 by 4 matrix, or so on. Let's say we have a 2 by 2 matrix. We have 1, 2, 3, 5. To find the inverse, we just use the power. So it's power -1. This means the inverse of your matrix. So this is the inverse of our matrix. Now, the last function we're going to discuss is the determinant of the matrix. How do we get this function on the calculator? Let's find the determinant of the very same matrix here. In order to get the determinant, we go to the catalog. So shift and number 4. We want determinant. So if I don't already have it here, I have to find it out by searching for letter D. Then I might plug in E also. So DET. This is DET. The determinant, then I enter the matrix. Let's say we have this matrix 2 by 2. Again, 1, 2, 3, and 5. So the determinant is -1. The determinant is always a scalar. It's always one number. So the determinant of a matrix is not a matrix. It's only a scalar, one number. That's it for today. If you have any questions, write them down in the comments.